Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 6, 2025, about 5 days ago. This paper proposes a geometry-grounded segment matcher that handles viewpoint shifts up to 180 degrees and beats strong baselines by up to 30% on the AUPRC metric. The paper is titled SegMASt3R, Geometry-Grounded Segment Matching. And as we will see later, the results are really impressive. Beyond raw matching gains, the method stays robust with noisy masks, transfers across datasets with light recalibration, and boosts downstream tasks like 3D instance mapping and object relative navigation, including plus 27 percentage points SPL in a sparse submap setting. That overview set the context. Figure 1 presents the pipeline from a wide baseline pair to matched segments. A frozen SegMASt3R backbone encodes both images and exchanges cross-view cues, producing patch features. A segment head pools these with masks to form per-segment descriptors. A differentiable optimal transport layer then matches descriptors, using SynchHorn to enforce near one-to-one assignments and a learnable dustbin, and a row-wise argmax outputs final correspondences. Alright, Figure 1 laid out the pipeline. Table 1 reports head-to-head results across pose bins on ScanNet++. The table shows that SegMASt3R leads every bin, with area under precision recall curve around the low 90s for small rotations, and still strong in the hardest 135 to 180 degrees, while also topping recall at 5. Dense local matchers beat sparse ones, yet pixel strength did not carry to segment level. SAM2 helped only at narrow baselines. So the previous table covered ScanNet++. Table 2 reports generalization to replica. The table shows that SegMASt3R stays on top across all pose bins, with area under precision recall curve near 95% at 0 to 45 degrees, and recall at 5 about 99%. The left block confirms strong small rotation performance. The rightmost block shows robustness under 135 to 180 degrees, where area under precision recall curve is about 68%, and recall at 5 about 95%. While both MASt3R variants drop sharply. Okay, the previous table covered replica. Table 3 evaluates generalization on the outdoor map-free dataset. The numbers show a domain gap for the ScanNet++ trained version at about 75 overall intersection over union, while simple dustbin recalibration lifts it to about 89. Retraining on map-free pushes performance to about 94 overall, which stays near 93 across all pose bins, a very consistent result. Well, the previous table covered outdoor generalization. Table 6 reports navigation performance when the matcher drives localization and RoboHop. The table shows consistent gains across all submap settings, with SegMASt3R topping every column. In the hardest case, span 16 and density 0.25, success weighted by path length jumps from about 36 to about 64, a 27 percentage point boost. Soft success weighted by path length also rises to about 79, which signals more reliable control. Well, Table 6 reported consistent gains. Figure 2 illustrates why the navigation gains appear. On the left, the DINOV2 variant mismatches the orange wall with the vanity cabinet, so the agent turns right and fails. On the right, the geometry-grounded matcher aligns the cabinet and nearby segments, which steers the robot into the bathroom toward the goal. The query and submap frames differ, but the qualitative contrast clearly shows more reliable segment associations. So, 2 takeaways stand out. A geometry-grounded backbone plus a simple segment head and SynchHorn matcher with a learnable dustbin delivers wide baseline segment matches that beat strong alternatives by large margins. And those matches matter. They lift 3D mapping and robot navigation substantially. Thanks for joining. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.